Good morning, everyone. We are from KKKL 2183 Theory Communicacy. Our project title is Secure Noise and Interference Management in 5G Mobile Communication toward Quantum 6G Networks. We choose this title because it clearly shows the main focus of our project. The title includes the current telecommunication system, which is 5G mobile communication, the main problem, which is noise and interference, and the future direction, which is quantum 6G networks. This title also matches our project objective because we want to study how noise affects communication performance and how future 6G technologies may improve reliability and security. The group members are Ren Haoting and Bai Renyang. In this presentation, we will explain how noise interference affected the performance of 5G mobile communication and how future quantum 6G networks may improve communication reliability and security. Future communication networks are expected to support higher data rates, lower latency, stronger reliability, better security, larger capacity, and higher mobility. At the same time, 6G networks are expected to improve current 5G technologies and introduce new technologies such as artificial intelligence, quantum secure processing, and intelligent network management. Therefore, our project focuses on the effect of noise and interference in 5G communication systems. We also discuss how quantum secure inference in future 6G networks may help to reduce these problems and improve communication performance. The telecommunication system chosen by our group is the 5G mobile communication system. 5G is a current communication technology that is widely used in daily life. It is used in mobile phone, smart cities, online video streaming, Internet of Things devices, and industrial automation. A basic 5G communication system consists of four main parts. First, the transmitter sends the information signal. Second, the channel carries the signal through a wireless medium. Third, the receiver receives the signal and recovers the original information. Finally, noise and interference are unwanted signals that disturb the communication process. Our group chose 5G mobile communication for several reasons. First, 5G is currently available and widely used in real life. Second, it supports high-speed data transmission and low-latency communication. Third, 5G is strongly related to the development of future 6G networks. Fourth, 5G communication is affected by noise, interference, signal fading, and network congestion. Lastly, 5G is suitable for studying the relationship between communication theory and real-world applications. We also chose this title because it connects three important parts of our study: 5G as the real communication system, noise and interference as the main technical problem, and quantum 6G as the future solution. Therefore, the title helps the audience understand the direction of our project clearly. Communication involves the transfer of information from one point to another. In this basic communication system, the information source produces the original message. The transmitter converts the message into a suitable signal for transmission. The channel is the medium used to carry the signal from the transmitter to the receiver. However, during the transmission, the channel may introduce noise, distortion, and interference. The receiver then tries to reconstruct the original message from the received signal. If the noise level is high, the receiver may not be able to recover the original information perfectly. There are several types of noise and interference in 5G mobile communication. The first type is thermal noise. Thermal noise is random noise generated by electronic components and devices. The second type is co-channel interference. This happens when different users of base stations use the same or nearby frequency channels. The third type is multipath fading. In this situation, the signal reaches the receivers through different paths because of the reflection from buildings, vehicles, and other objects. The fourth type is electromagnetic interference. This is caused by unwanted electromagnetic signals from nearby electronic devices or communication systems. All these factors can reduce the quality of the received signal. Noise and interference can reduce the performance of 5G communication systems. One important effect is lower signal-to-noise ratio, or RNS. When RNS decreases, the useful signal becomes harder to distinguish from noise. Noise can also increase the bit error rate, or BER. This means small bits may be received incorrectly. Other effects include lower data transmission speed, higher latency, unstable connection, packet loss, retransmission, and lower reliability. As a result, users may experience lower internet speed, video delay, poor call quality, or unstable network connection.
Real-world application experience. 5G is commonly used in remote health care. It enables real-time video consultation, patient monitoring, and other medical surveillance. Noise and interference will worsen communication quality. Videos may become unclear or delayed. Medical data can be transmitted wrongly, and network communications will be unstable. This problem affects real-time monitoring and threatens the safety of medical survivors. This experience shows how communication theory works in real life. Simple calculation of noise effect. We use calculation to show how noise influences communication performance. The 5G channel bandwidth is 100 MHz. In low noise conditions, the signal power is negative 75 dBm and the noise power is negative 95 dBm. We work out the signal-to-noise ratio as 20 dB using the Zenon capacity formula. The chamber capacity research is about 666 megabits per second. High noise conditions. When noise increased, the signal power stays the same, while noise power raised to negative 85 dBm. The signal-to-noise ratio drops to 10 dB, and the channel capacity falls to around 346 megabits per second. This comparison tells us the more noise leads to low signal quality and slowly data speed, which weakened the overall system performance. Quantum secure inference in future 6G. Quantum-related technological sets will help 6G networks become safer, more reliable, and more efficient. First, quantum error correction fixed errors caused by noise. Second, the combination of quantum and traditional systems brings more advantages. Third, artificial intelligence can find and reduce noise and interference automatically. Finally, smart network management adjusts resources based on real-time network conditions. Conclusion. To sum up, noise and interference are key issues for communication systems. They reduce signal quality, increased data errors and network delay in 5G. Research on 5G helps us understand the practical using of communication theories. With quantum security, artificial intelligence are error correction technological. Future 6G will provide better communication survivors. Imagine noise and inference will also be important for network development. Our references include the course materials and lecture slides for KKKL 2183. We also refer to Claude Samnon's research paper, RTU Optical Science and Technical Artificials about quantum information processing. Thank you for listening to our presentation.